We all want our apps to feel incredibly fast, responsive, truly native class. But what happens when that gorgeous UI you spent weeks building just stops? Today, we're going to look at how to transform that sluggish, clunky experience into something that feels amazingly fluent. And the best part? The fix is often just 2 lines of code. You know this feeling, right? That sinking feeling when the screen starts to flicker, the app just completely freezes, and your poor user is left staring at an unresponsive window. It is a pain every single developer has felt, and it's the exact opposite of that professional, native class experience we're all shooting for. Now, I know what you're thinking. That sounds way too good to be true. But believe me, it isn't. The solution is shockingly simple, yet the performance gains are just massive. Let's break it down. All right, first up in our little performance investigation, the flicker and the freeze. This is that moment your app's performance just smacks right into a brick wall. So what's actually happening under the hood? So here's the core of the problem. By default, every single time you add an item to a list, you're basically telling the UI, hey, redraw yourself. Now imagine you're doing that thousands of times in a loop. The system just gets flooded with repaint requests it can't possibly keep up with. That's your freeze. That's your flicker. It's a traffic jam of paint commands. And look, this isn't just some abstract idea. A developer, Jerry Dodge, tried a basic fix. And sure, it helped a little. But, shaving 1 second off a 6-second wait, that's not the game changer we need for that snappy, native-like feel. We need something way more powerful. And that brings us to the solution. I like to call it the do not disturb pattern. It's incredibly simple to use, but the impact is absolutely massive. So here's how it works. Calling begin update is just like hanging a do not disturb sign on your UI component store. You're telling the interface, hey, listen, I'm about to do a whole lot of work in here. Just ignore everything until I say I'm done. You can then add, delete, or change thousands of items, and the UI won't even blink. Once you're finished, end update takes the sign down, and that triggers one single super efficient repaint to show the final result. And you won't believe how easy this is to implement. On the left, you see that standard, slow, guilty loop. On the right, it's the exact same logic, but it's wrapped in our 2-line fix. Begin update at the start and end update at the end. That is literally it. Okay, now for the payoff, the moment of truth. Let's look at the results. We're loading 2,000 items into a FireMonkey list box. Without our pattern, it takes a painful 25,000 milliseconds. That is 25 seconds of a frozen screen. With our 2-line fix, just 125 milliseconds. The difference is just staggering. Yeah, you heard that right. Let that sink in for a second. A 200 times performance improvement. We are not talking about some small, incremental tweak here. This is a fundamental transformation in the entire feel of your application, making it perform like a true native app. And that is the power of the do not disturb pattern. It is, without any exaggeration, the difference between an app that feels kind of clunky and amateurish and one that feels professional, responsive, and truly native class. Okay, that's just incredible. But how does it actually work? Well, under the hood, the 2 main UI frameworks, VCL for native Windows apps and FireMonkey for cross-platform, they actually achieve this in completely different ways. So the VCL, which is basically a direct line to the Windows operating system, it essentially tells Windows itself to just stop painting the control for a minute. FireMonkey, on the other hand, since it's a cross-platform framework, it handles it all internally by suspending its own layout and painting cycles. So you have 2 different methods, but the result for you, the developer, is exactly the same, a beautiful, flicker-free update. All right, so we get the what and the why. Now let's talk about the how. This is the professional's playbook for implementing this pattern correctly and writing really stable, high-performance code. Okay, you gotta lean in for this part. Seriously, if you remember absolutely nothing else from this explainer, remember what's coming up next. This is the golden rule. You must, and I mean always, wrap your update code in a try finally block. Why? Well, think about it. What if an error happens while you're adding items? Your code could crash and just jump right out of the procedure. If that happens, end update never gets called, and now your component is permanently frozen. The finally block guarantees no matter what happens that end update will be called. This is completely non-negotiable for professional-grade code. Want to take it to the next level? Here are a few more pro tips. Before you fill a big list, preset its capacity property to avoid all those slow, constant memory reallocations. For memos, build your text in a separate string list first, then just assign it all at once. And for really complex controls, like a tree view, this pattern isn't just nice to have, it is absolutely critical. But what about truly massive datasets? Well, for datasets with tens of thousands or even millions of items, you need the ultimate solution, virtualization. This is a brilliant technique where the UI control is smart enough to only load and draw the items that are currently visible on screen. This is how apps let you scroll through millions of records with that same instantaneous native feel as scrolling through just 10. Okay, let's just zoom out for a second. Because at the end of the day, this isn't just about technical tricks to make performance numbers go down. It's really about something far more important. Because really, the big takeaway here is that creating a fluid, responsive UI is a fundamental part of the user experience. It's a sign of true software craftsmanship. And that brings us to the final point, which I think is captured perfectly right here. This isn't just about speed. It's about respecting your user. Respecting their time, their patience, and their attention. A Fluent UI shows that you, the developer, actually care about their experience. So I'll leave you with this one final question to think about. Is your code truly respecting your user? By applying simple but incredibly powerful patterns like the one we've talked about today, you can make sure the answer is a resounding yes.